Today I wanted to talk about superior highly composite numbers. So generally there's an idea called highly composite numbers, and those are numbers that have more divisors than any other number smaller than itself. So like 12, for example, 12 has more divisors than every other number smaller than it. But a superior highly composite number, you can see by the definition here, it's just a number that actually has more divisors than a positive power of any number. Um, and you can see the whole equation there. So any superior highly composite number would have more divisors divided by a power of itself compared to any other number. So it just means that it has a lot of divisors, even compared to other numbers with a lot of divisors. And the reason why I thought this was interesting was because I actually had a little bit of a weird idea. I was thinking about how usually in music we use uh, 12, 12, the chromatic scale, the 12-tone scale, to go from one octave to another, right? So to go from C, like let's say C4, right? To go from one C to another C, right? C5, we go through 12 notes in total, right? Of course, that depends on, there's smaller scales in between, right? Like the major, minor, different scales and different modes. But of course, on the piano, right, for example, there's 12 keys, right? 7 white keys and 5 black keys, right? 12 keys in total for one octave. And I thought that was really interesting. It could just be coincidence, but I was thinking that since 12 is actually one of the highly superior, highly composite numbers, um, and since with a lot of chords, they have basic ratios, right? Like 3 to 2, 4 to 3, 5 to 4. They have basic fractions that makes them sound really, that makes the chord sound really good. So I was wondering if it was possible to make a 60 tone um, scale, you could say. So there's 60 equal tempered tones in total between one C and another. So it takes 60 microtones in order to get to one full octave. And this is only for equal tempered. I don't know. I haven't messed around with anything like mean tempered or any other um, more exotic temperaments. This is just equal temperament. And so first I wanted to go through, I'm actually using musescore, and I'm using this plugin called the Zen Harmonic Tuner. And I already just I made a JSON file just specifying how many cents to go up per note, and it'll go up, every note um, will go up by 20 cents, right? So 100 cents is one semitone, and since there's 12 semitones in total, and 100 cents is one semitone, I just had to divide it by a fifth, right? And then that would give me the whole octave um, for 60 tones. So this is what I guess the scale, the 60 tone scale would sound like. And then the last one at the end was just to compare the, I guess you can call it like the C. It's not really a C, but um, the note and the note one octave above it, because that would be 60 tones in total. I don't really know what it sounds like. I've never heard any musical system that sounds like this because it sounds, to be honest, it sounds pretty terrible. Or at least I wouldn't know of any way to like compose music. It's a little bit it's a little bit much for me. But I did want to. Um, and there's also a little bit of like audio glitching too. The plugin isn't perfect, so there's a little bit of reverb going on. So the audio quality isn't perfect, but it kind of shows what it would sound like. And this is what. Oh, so first let me play the regular version, just a normal version of or 12 tone version of Mary Had a Little Lamb. I'll just change it back to regular equal temperament. Just good old Mary Had a Little Lamb. And this would be what it would sound like in the 60 tone temperament. It's actually spaced exactly the same. I'm using the exact same notes. But this is just to show you like the weird audio glitch that I was talking about. And yeah, it sounds very flat. Yeah, it sounds very, very flat. Um, it almost sounds like a kind of like a twangy sound, like a twang. Um, I tried making some chords using the 60 tone scale. Didn't turn out so turn out so hot. Yeah, it just sounds like a bunch of noise basically. I think that sort of makes sense because as the ratios get closer together, they tend to sound like if you start getting like more complex ratios, like let's say 8 to 9, right? Like a frequency ratio of 8 to 9 or 11 to 13, it starts sounding really almost chaotic. And no, with a 60 tone scale, it's just really hard for my ears to pick up any sort of like pattern um, in the scale. Uh, but I do hope someone found this interesting. Let me know if you play around with 60 or any other sort of like temperaments or scales. And if you do have like a cool temperament that you really like, please let me know. Otherwise, I hope this inspired or made someone more curious about superior highly composite numbers. That's a mouthful.